it must have low ionization energy for the metal atom. If the metal atom which is having lowest ionization energy, those metal will form what? Ionic bond. Suppose if the bond which exists between the two different elements or two different atoms, how much of the energy is required to break that bond, that is known as bond enthalpy, and it is expressed in kilojoules per mole. Hello my dear students, a warm welcome you all. Myself is Ma, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Chemical Bonding and Molecular Structures. Under that, we have discussed about the chemical bond and we have learnt about the Lewis approaches to the chemical bond, and we have learnt about the types of chemical bond. In that, we have deeply discussed with the covalent bond and its example. And also we have learnt about the Lewis representations of some of the important molecule, and we have understood that what is informal charge and how to calculate the formal charge by using ozone as an example also we have discussed. In addition to that, we also discussed about the limitations of octet rule. Today, let us move on to the next topic of this unit about the ionic or covalent bond. And we are going to understand the factors which are affecting to the ionic bond. And finally, by taking the example of BORN-HABER'S cycle, we are going to understand the ionic bond, and later we are going to understand the bond parameters. Under that, we are going to understand bond length, bond angle and bond order, as well as with the resonance structure. Okay. Now we are going to learn more about the ionic or electrovalent bond. So already we know that an ionic bond which are formed by complete transfer of electron which is there in the outermost shell of an atom. Okay. If you consider any two atom, if it shares the electron which is present in its outermost shell, that leads into the formation of what? Ionic bond. So the ionic bond which is formed by complete transfer of one or more electron from the outermost shell of an atom to the outermost shell of the other atom. Okay, or you can define it like this also: electrostatic force of attractions which owes the oppositively charged ion, which means to say that, for example, if you take sodium chloride, we know that the sodium metal which loses one electron which is present in its outermost shell. Is it right? So it forms what? It becomes cation when it loses its one electron. Is it right? Similarly, that one electron will be accepted by a chlorine atom and gets a negative charge and behave like a anion. So this force of attraction between the cation and anion, together it is also known as ionic bond, or this force of attractions which makes these cations and anions to form a ionic bond. Let us deeply discuss with the sodium chloride. We know that the sodium has an electronic configuration of 11. Similarly, the chlorine has an electronic configuration of 17. Is it right? In that, okay, the sodium which consists of one electron which is there in its outermost shell. Similarly, the chlorine atom has a 7 electron in its outermost shell. In order to get a stable electronic configuration, the sodium which loses one electron and become what? Sodium plus. The chloride, that loses how many? That accepts one electron and becomes what? Chloride. That is, it becomes a negative charge. So here, sodium loses one electron, that electrons will be accepted by the chlorine to get a stable electronic configuration of chlorine. Okay, this is how we can easily understand where the electrostatic force of attractions will exist between the cations and anion and results to the formation of ionic bond. So this ionic bond which is also get affected by the many factors. So the factors which are favoring to the ionic bond, an ionic bond which are made up of a metal ion and non-metal ion. Already I have explained that by taking the example of sodium chloride. In that, sodium is a metal, whereas the chlorine is a non-metal. So sodium becomes what? Cation. Similarly, the chlorine will become anion. So, an ionic bond which is made up of metal ion and non-metal ion, and these are also favors some of the conditions. It must have low ionization energy for the metal atom. If the metal atom which is having lowest ionization energy, those metal will form what? Ionic bond. Similarly, with a high electronegative value, or you can say that it must have a high negative value of electron gain enthalpy. So, in the chlorine, we can see that there will be a higher amount of electron gain enthalpy will be produced after accepting one electron from the sodium atom. And coming into the higher value of lattice energy. So, these are the three conditions which favors the ionic bond. One is the metal should have what? Low ionization energy, and it must have what? Higher lattice energy. And third one, it should have a higher negative value of electron gain enthalpy. So, we have understood that what is electron gain enthalpy as well as with the ionization energy in our classifications of the element chapter. Is it right? So, today we'll understand what is that lattice energy we call it as. Okay. It is a amount of energy which is released when oppositively charged gaseous ions combine to form a 1 mole of solid ionic compound. You can see that the sodium combines with a chlorine. Okay, it forms what? Sodium chloride. So, in this example, both of the elements, one is solid state, one is in a gaseous state. Okay, it combines to form what? Solid. So, that is known as lattice energy. So, it is the amount of energy released when oppositively charged. Sodium is a cation. Similarly, chloride is an anion. So, when they combine together, results in a formation of solid ionic crystal. That is why when a sodium which is reacting with a chlorine, it forms a salt known as sodium chloride or table salt. That is known as what? Lattice energy. So, these are the conditions which favors what? Ionic bond. Next, we'll see what is a BORN-HABE'S cycle, how we can predict the formation of sodium chloride by using BORN-HABE'S cycle. Let us understand now. It is a cycle of operation representing energy change during the formation of 1 mole of an ionic crystal solid from the required element. Here, I have taken out the formation of sodium chloride. In the first step, what will happen? Sodium is a solid. When it is combined with a gas called as a chlorine, it forms what? Sodium chloride solid. Is it right? What will happen? In the first step, sublimations of the sodium atoms to the gaseous sodium atom will be taking place. So, in that what will happen? The sodium solid will be get converted into sodium in the gaseous state, where this process of converting solid into gaseous phase, it is known as what? Sublimation. In the second step, what will happen now? The dissociation of the chloride molecule to form a chlorine atom will be taking place. You can see that this is a chlorine molecule which undergo dissociation and forms what? Chlorine atoms. Which forms what? Chlorine atom. In the third step, ionization of the sodium will be taking place, which means to say that sodium will loses 1 electron and gets the positive charge. These are the first 3 steps, where in the first step, always remember sublimations will be taking place, where the solid sodium will be converted into gaseous sodium. In the second step, the chlorine molecule which undergo dissociations and forms a chlorine atom. Whereas in the third step, what will happen? The sodium which loses 1 electron and gets a positive charge, and this process which is also known as ionization of sodium. In the fourth step, electron affinity of a chlorine will be explained. We know that the neutral chlorine atom gains 1 electron to get a Cl- ion, and energy will be released, which is also known as electron affinity, which is also known as what? Electron affinity. You can see that the chlorine which are accepting one electron and becomes a negatively charged anion. In the fifth step, it is known as lattice energy. Why it is lattice energy? Because we have understood just now that lattice energy is nothing but the amount of energy which is released when oppositively charged ions are combined together to form a solid ionic crystal. Is it right? Here also the oppositively charged sodium ion combines with chloride anion and forms what? Sodium chloride. Which forms what? Sodium chloride, and sum of all this energy will be the heat of formation of sodium chloride crystal from the sodium and chlorine. This is how we can easily understand that how the sodium chloride will be formed from the sodium solid and from the gases called as chlorine. Okay. So we have a general Haber's process we can also represent like this. So you can see that in the first step what will happen, the sodium solid will be converted into sodium gases, and this process which is also known as what? Sublimation. In the later process, it undergo what? Ionization, and it loses one electron and becomes sodium cation. So this is a cation which is formed. So in the second step, what will happen? Again, the chloride which undergo what? Dissociation. Undergo dissociation and forms a chlorine atoms, and this chlorine atom which accept this electron and become chloride anion. This cations and anions, when it is combined, results in a formation of sodium chloride. This is how, by using Haber's processes or Born-Haber processes, we can easily understand that how the ionic bonds will be formed between two oppositively charged elements. Okay. Next, we will look into the bond parameters. So in this, we have a plenty of bond parameters. We'll understand one by one. So first I'll go with the bond length. Bond length, that is defined as equilibrium distances between the nuclei of a bonded atoms in a molecule. So it is nothing but a distance, equilibrium distances between the nucleus to the two bonded atoms, which is known as a bond length. So for example, while writing the water molecule, okay, we say that between the oxygen and hydrogen it has 135 picometer as a bond length. What does it indicate? Between the two bonded atom, whatever the equilibrium which exists, that equilibrium distance we call it as a bond length. So what is the bond length? It is the equilibrium distances between the two bonded atoms. Okay. Next is covalent radius. Covalent radius is a half of the distances between the two similar atoms joined together by a covalent bond in a same molecule. Here we can understand this covalent bond. Here you can see that this is a two molecules and we know that this is a radius. Is it right? This is a radius. This is a center of the nucleus. Is it right? Yes. So when I say it is a covalent radius, it is a half of the distances which is found in each molecule, and sum of these two half of, which is also known as what? Covalent radius, which is obtained by adding the distance from the center of the nucleus to the outermost shell of an atom. So if any two atoms are there, if they are forming a covalent bond, the distance from the center of the nucleus to the outermost shell and the distance from the center of the nucleus to the another elements, that distances together, it is known as covalent bond. You can understand that covalent bond by writing any two atoms whose distance from the center of atoms to the outermost shell will be considered, and it is named as covalent radius. Okay. So covalent bond is a sum of two covalent radii of the two combining atom. So the covalent radius of the carbon atom and hydrogen atoms are pm and 37 picometer respectively, and hence the covalent bonds length between the carbon and hydrogen atom is obtained by adding 77 plus 37, which gives rise to what? 114 picometer. This shows that we can easily calculate the covalent radius by adding what? By adding covalent radius of the each element. So if you add the covalent radius of the hydrogen along with the covalent radius of the oxygen or with the carbon, you will get a covalent bond of or covalent radius of that particular element. Okay, so this is how the first two parameters will be defined and it will be measured. Next is van der Waals radius. The van der Waals radius represents the overall size of an atom, which includes its valence shell in non-bonded situation. Further, we can say that the van der Waals radius is a half of the distances between the two similar atoms is in separate molecule in a solid. So when we talk about this van der Waals radius, we can clearly understand about the overall size of the atom. Here I have an example here. You can see that these two are the one molecule. Consider this is a carbon and this is a hydrogen. Similarly, you can consider this is a carbon and this is a hydrogen. Okay. You can see that the distances between the overall atoms, that was indicated by what? Van der Waals radius. You can see that this is the center of the hydrogen, this is the center of the carbon atom, and you can see that these two are get separated by a imaginary line, and we know that what is the covalent radius? It is the half of the distances between the two bonded atom. So that is a covalent radius, and you can see that the distance between any two atoms, this is a one atom and consider this is a another element. So this is a one element and this is a another element. The distance is what we are measuring, that is known as van der Waals radius, and it gives a clear picture about the overall size of an atom which is there in a bonding processes. Next is bond angle. It is an angle between the orbital containing bonded pairs of electron around the central metal atoms in a molecules or ion. Here you can see that this is ammonia. You can see that these two are the bonded atoms. One is hydrogen, one is nitrogen, and you can see that there is a one more hydrogen. So between the two bonded atom, you can see that we have a bond angle around 107. Okay, this indicates that bond angle is an angle which exists between the two bonded atoms which are having bond pair. Similarly, you can see that here this is a central metal atom, and between these two hydrogen atom in the methane, so it has what? 109.5 degree. Similarly, if you consider the water molecule, we have a central metal atom which having two lone pair of electron, and these two hydrogen atoms are get separated by the bond angle of 104.5 degree. This is how we can easily remember what is an bond angle. So what is a bond angle? It is a angle which exists between the two bonded atom having a central metal atoms with a lone pair of or bonded pairs of electron. Next is bond enthalpy. It is defined as amount of energy required to break 1 mole of bond of a particular type between the two bonded atoms in a gaseous state, and it is unit of the bond enthalpy is kilojoules per mole. Suppose if the bond which exists between the two different elements or two different atoms, how much of the energy is required to break that bond, that is known as bond enthalpy, and it is expressed in kilojoules per mole. Here we have an example for that. So hydrogen-hydrogen bond enthalpy in hydrogen molecule will be around 435.8 kilojoules per mole. You can see that this is a hydrogen molecule. Is it right? This is a hydrogen molecule. In order to break between the bond between the two hydrogen atom, we require some of the energy. How much of the energy is required to break a single covalent bond between the two hydrogen atom? It is around 435.8 kilojoules per mole. Similarly, the bond enthalpy for the molecules which are containing a multiple bonds. So here I have talked with a single bond. Suppose if the double bond which is there, what will be there? Bond enthalpy, you can see that in case of oxygen molecule, there is a formation of two double bond between the two oxygen atoms. So how to break that double bond? So for that we require some of the energy. Here that energy which is nothing but 498 kilojoules per mole. So this amount of energy is required to break double bond between the two oxygen atoms. Similarly, in case of nitrogen atom, we know that there is a triple bond. In order to break the triple bond, we required 946.0 kilojoules per mole. If it is a single bond, if it is a double bond, or if it is a triple bond, amount of energy is required increases from the single bond to the double bond, later to the triple bond. That is known as bond enthalpy. Next is bond order. Bond order is given by the number of the bond between the two atoms in a molecule. So, for example, if I write hydrogen and hydrogen, we know that in a hydrogen molecule, is it right? There is a single bond will be there. Hence, the bond order will be 1. Bond order will be 1. Similarly, if I write oxygen molecule, in case of oxygen molecule, what will be the bond order? It will be 2. Similarly, if you take nitrogen molecule, it has a bond order of 3. So, which indicates that bond orders are nothing but how many number of bond which is exhibits between the two atoms in a molecule, that is known as bond order, and it can be easily calculated. Next is resonance structure. Whenever a single Lewis structure cannot be described by a molecule accurately, we go with the resonance structure. Is it right? Yes. The number of structure with a similar energy and position of the nuclei and bonding and non-bonding pair of electron will be taken as canonical structure of hybrid, which describe the molecules accurately. That is known as what? Resonance structure. So, resonance structures are usually represented by double-headed arrows, and in case of ozone molecule, the two structure will constitute the canonical structure and the resonance structure and their hybrid. That is, the third structure represents the structure of ozone molecule more accurately and is known as resonance hybrid. So, when we will write the resonance structure? Only when the Lewis structure of the particular molecules which is not described at all. In such situations, we will go for writing the canonical forms of single elements. Okay. Here I have an example of ozone. You can see that in ozone, there are 3 oxygen atoms will be there, and between 2 oxygen atom, there is a single bond. In between another 2 oxygen atom, there is a double bond. Is it right? And the central oxygen atom has a 2 lone pair of electron. Similarly, this is a end oxygen atom. This is the one, you can take 2 and 3. So, this oxygen atom which is having 6 electrons, and whereas in the another end of the oxygen atom which also consists of 6 electrons. You can see I have written the another form of this ozone molecule. So, you can see that which is having 2 electron, and here also the ended oxygen atom has a 6 electron and another 6 electron at the other end of the oxygen atom. So, when you are writing this resonance structure, by keeping nucleus as well as the bond angle, and then you can see that the bonding and non-bonding pairs of electron as a constant, we will write its structure. We call this structure as a canonical structure. Here you can see that the structure 1 and structures 2 are the canonical structure of the ozone molecule. Whereas, by writing that canonical structure, we can easily write the exact structure of that molecule, that is known as hybrid structure. So, this is an actual structure of the ozone molecule, and it is also known as resonance hybrid. How we will write the resonance hybrid? By writing the canonical structure of the first and the second one. So if you write that canonical structures, similar structures, then only we can easily write the resonance structure. Next we'll see what is a polarity of the bond. When covalent bonds are formed between two different atoms, the shared pair of electron is attracted near to the more electronegative atom. As a result, the electronegative atoms gets a partial negative charge and less electronegative atom gets a partial positive charge. And the resultant covalent bond is polar covalent bond. So in the last class only we have understood that what is an covalent bond. So we have understood that covalent bonds are formed by mutual sharing of the electron between the any two atom. Is it right? And we have learned the example of two chlorine molecule where each chlorine atom will share one electron. Mutually it will share its electron and leads to the formation of single covalent bond. Suppose if any two elements if you consider in that, if more electronegative elements are there, the partial negative charge will be goes to the element which is more electronegative in nature. Similarly, if the elements are less electronegative in nature, it get the partial positive charge. Such elements are known as, such element it gaining that partial negative charge and partial positive charge, they are known as what? Polar covalent bonds. Okay. Example, the HF, that is hydrogen fluoride, it shares electron pairs between the two atoms and get displayed more towards the fluorine because fluorine is the electronegative than the hydrogen. Is it right? So, in case of fluorine atom, we know that the hydrogen which is having the valence of 1. Similarly, the fluorine which has how many valency? We know that fluorine has an electronic configuration of 1s2, 2s2 and 2p5. Is it right? So, when you are writing this, we can clearly understand that there are 5 electrons will be present in its outermost shell. So, it requires one more electron. That is why it will share one electron from the hydrogen atoms and forms a HF bond. So, doing this bond, the more electronegative nature of the fluorine, because of that nature, fluorine gets a partial negative charge. So, while doing the bonding, we can clearly understand that hydrogen is less electronegative than that of the fluorine. Hence, it gets the partial positive charge. This kind of bond which is formed during the mutual sharing of electron, that is said to be polar covalent bond. So, hope you are understood with this concept. So, in the next class, we are going to understand more about the dipole moment. By this, I like to say that which are all the things which I covered in this session, especially with the ionic bond with the example as well as with the bond parameters. Have a look on it and try to note down. We'll meet you with the next session. Till that, take care, be safe. Thank you.